I'm working on a project to do some AC powered control and interfacing. So I had this dinrail. How do you get this on? I mean, it doesn't really push, huh? Oh, jeez. So I gotta. It should just clip on. That one wasn't designed very good. Oops. Now that's gonna be a problem. Those tabs stick out like that. Yeah, see, that's the way it's supposed to go on. That tab is too big. So this is a relay adapter for a Omron. This is a Omron G7L. It's let's see, 3 horsepower, so 30 amp or whatever. 30 amp, 120 volt here is what we use. So this is the control motor. You know, nice beefy load, and you can swap that out. You just have a base. So I'm going to wire up. This is some AC control. This is a fuse input in line. Also, you can use it as a disconnect. And then I'm going to power it through this. Where does this go in? And so I'm going to figure out how I'm going to lay out this rail. I was going to put it in this box, but I don't know if this box is going to be big enough for what I want to use it for. I could do 2 rails, or maybe I could do like a layered. They have layered rails, staggered, so maybe I could put some standoffs. Because I'm going to want some decent separation of ground and power. I mean, power and data, high voltage, low voltage. I mean, so the idea is that this will be over here, and then I'll have a grounding rail. Let's slide that on. Now, I'm just get a screwdriver. This is a grounding rail, a grounding connector. You just tighten that up and it grabs onto the rail. And so that gives you your ground connection. Oops, jeez, this thing's cheap. To glue that together. So that's for grounding. It grounds to your rail, and then you can ground to whatever. And you have these guys, which are just straight through connectors, and they just go on there like that. Do I have that the right way? No. Alright, so you'll bring in power, and if you want to make a bus, let's see your did I put them all the right way? Yeah. So you have your power there. You bring in your, neutral, line, whatever. And then you can use a jumper to connect them all. So you bring in your one and then you take out all your tap-offs. Or you can use something like this. And these basically are bridges. And they just go down like that. And then you just screw them in. And then it'll bridge all your connections. You can break these, cut them down to the size you need. Oops. Another thing you can do is you can see how they bend a little bit. You can snap them where you want them. And it's not recommended, but you could just not screw it into the block you want it on. But these ones seem like they'll touch. I think these ones are not like that. These ones seem to bottom out and touch the contacts. So you can't really skip over. If you put that in, you can't skip one, but because it's still going to touch. And they have different heights of these you can buy and all different stuff like that to do different things. And you just cut that where you want it. That's pretty much the basics of dinrails. There's a lot of these are just generic Chinese clones of Wagos and different kinds of connectors, the standard connectors. So these are a pretty generic standard version of these. It says it's IEC 947-7-1, 690 volts, 32 amps. I guess I should check these and see if they're fire retardant. I'm going to guess they're not. They have a couple features on them. This is the clip. This is how they create the spring to grab the rail. Right there. They have a pass-through here, so you can, I think you can run wires through. I'm not really sure what that's for. I've never seen that used. These little slots here with the ribbing, that's for labels that go across on both sides. And they just, like I said, there's, different colors you can get. I'll use gray for power and I'll use blue for data. And you just put them on there. And then you have a dinrail. A lot of times you can take these off. There'll be a slot to pull. These have these little slots over here. You just pop them off. And that's pretty much it. There's not much to it. Looks complicated when you see them, but it's not really. You're just wiring up circuits. It just gives you a nice organized modular way to do it. And these come in all kinds of variations. There's they can get really expensive, of course, because they're for industrial control. You can get power supplies that go on here. So I figured I'd make a little case to put some, put a control board on here, some relays, and then this master relay for the electrical control. Maybe I'll put that somewhere else. Maybe I'll put that on its own separate rail. And then I'll just put an Arduino or an ESP over here or something like that. For example, I have like a power supply. This is a 24 volt. But there's some other stuff you can put on there. And hopefully this will not get too hot in the area I'm putting it on. Let's see what kind of fuse that goes in there. Yeah, so I got like a whole box of these for fairly cheap. You know, I got this whole thing. And there's dividers you can get. I have some coming. You want an end cap because on this side it's open. So, you know, on your last one, you'll want an end cap, or you can get dividers to divide stuff and stuff like that. You can get these in push connectors, or screw downs, or all kinds of stuff for all different size wiring. You know, there's an Arduino case that you can put in an Uno in here. All kinds of stuff. So I'm probably going to 3D print some brackets today for these. That's dinrails. I'm not an automation person. I don't know everything there is to know about them. I've used them before, and I really like the system. Even for hobbyists, it's you know, if you're going to be doing something that's highly organized and modular and upgradable, then this is how you want to do it. You know, you can make a bunch of boards with some little terminal jacks and stuff on that, but this is going to be much more universal in as far as over time upgrading it and changing it. And like I said, you get these bridges, and you can link any of these together in groups of whatever. You know, so if I want to upgrade this to whatever, I could put a divider in there, or like a color divider, or different color ones. And then now I could bridge these and these, and then this becomes, you know, ground, and that becomes VCC or GPIO 1, 2, 3, 4, whatever you want to do. The only problem is, you know, this is a 1-to-1 connection. So it's not like when you're trying to splice something, you get 1-to-2. Think of these as like wire. You know, you shouldn't put more than one wire in there. You can do it if you wanted to. You're not supposed to. Like any terminals, you're not supposed to put 2 wires in. If you're going to put 2 wires, you want to put them into a ferrule, crimp them together. Let's see if these ferrules fit. I just bought some ferrules. So you'd put your wires in here, crimp it, and then instead of putting your stranded wire in here, well, these aren't really big enough. They're not deep enough. So maybe they make different ferrules that are made to go in here, because those wires, these are obviously for bare wire, because it goes really deep. I mean, you can maybe get it in there. Oh, the screwdriver's too small, too big, I mean. Yeah, it kind of doesn't really reach in there. I'll show you. See? That one's not open. Go ahead and open this one up. See? I mean, you can get it in there. Yeah, see, it goes all the way in. And then you'd screw that down. And then you have the wires crimped in there. And there would be no frayed wires or stranded wires, you know, twisted together or coming out. I don't know what gauge this is. It might be a little too big. It's hard to get these in smaller gauges unless you buy the big pack. And this is just a this is just like two metal cages that crush against a little bar. That's it. And sometimes they'll have 1 to 2 you can get. They'll have ones that are multiple levels, so they'll be wider. They'll have a secondary level down here of another pass-through. And sometimes you can put a pin through the middle and bridge the two. And there's all kinds of variations of these that you can buy. Of course, they get expensive because they're made for companies with lots of money, so they're industrial solutions. It's hard to find cheap. These cheap Chinese ones that's pretty much no names. And I wouldn't trust the ratings on them or anything like that. But for what I'm using it for, I'm also not using this in my house. If I was going to do this in my house, I would probably buy I'd spend the $100, $200 and buy a good collection. You can go on eBay and find industrial automation panels where they pulled everything out and they're just selling a whole rail of all these for like $70 or something like that. It's a really good deal. If I was going to put it in my house, I'd buy something that's, real. This is going to be out in my yard. I'm not terribly worried about it burning my house down. So that's it for dinrail. So I'll go into this project a little more. It's mainly going to be a yard control system for lighting, my pool pump, sensing for my pool, and sensing for environmental. Might be a weather station in there. So it's going to get expanded. That's why I'm choosing to do it this way. I'm probably going to have a panel. For now, I'm just going to probably use this to control the relaying and the power. But eventually, I'm going to have a panel to control everything as a center hub in my yard for if I want to do landscape lighting or environmental reporting or solenoid control for water and irrigation and all that stuff. And then, alarm system stuff, motion detection, automation, turning lights on when you need light in a certain area. So all kinds of stuff you can do. And I can bring in data of a twisted pair, RS422, 485, or just one wire sensors. They should be good up to a couple meters. And I2C, I'm not really sure. To keep it local, like a weather station, I could probably use I2C, and for sensors and stuff like that, I'd probably put wireless in here. And just have control over something that I want to add. I want to just add something in, I pop it in there. Now I have temperature, humidity, UV sensing, and stuff like that. So that's how I'm going to do some kind of modular system. And then I can always expand on it and see what works. I can make boards and stuff that go on here for control. You would just make a bracket, and you can buy brackets that snap on here. You can buy proto boards that snap on here. All kinds of stuff available. Of course, I'd probably just make my own with a 3D printer. But yeah, so that's how that goes. And that's it for now. I'll keep you updated with this project, and we'll see how it works out. Maybe I'll do a video on putting it together. Probably not. It's going to be really hot. I'm probably going to be in the yard. It's going to be a pain in the neck. So, till next time.